Students, we have been discussing the lesson number 2. In that lesson, various concepts we have seen, various atomic models and the models of atom proposed by different scientists. And finally, we saw about quantum mechanical model and Schrödinger wave equation. Dear students, in this video, we are going to discuss about the shapes of atomic orbitals. Okay, we know about orbitals. Can you please remember what is called as orbital? An orbital is the space around the nucleus where the probability of finding the electron is maximum. அதாவது நியூக்ளியஸை சுற்றி எலக்ட்ரான் எந்த பிளேஸில் இருக்குதோ that three-dimensional region is called as orbital. That we know. Electron inge present irukudho, that region is called as orbital. Now we have 4 different types of orbitals: S orbital, P Arbitral, D Orbital and F Orbital. So we are going to discuss about their shapes, how the shapes are given to those atomic orbitals. Let us start with Schrödinger wave equation. Students, we know what is called as time independent Schrödinger wave equation. Can you please remember? Yes, it is H cap psi that is equal to E psi. That is the time independent Schrödinger equation, and it cannot be solved for all the values of energy. This equation can be solved only for a particular values of energy, and those energy values are called as eigenvalues. And while solving the Schrödinger equation, we'll be getting a corresponding wave function. That wave function is called as atomic orbitals, isn't it, students? The Schrödinger wave equation is H cap psi is equal to E psi. This equation can be solved only for certain values of energy, and that certain values of energies are called as eigenvalues. And while solving, the corresponding wave functions are obtained, and those wave functions are eigenfunctions and also termed as atomic orbitals. Okay, so that is given here. The solution of the Schrödinger wave equation for one electron system like hydrogen can be represented in the form of spherical polar coordinates. While so the solution of the Schrödinger wave equation can be expressed in terms of r, theta and pi. Okay, Schrödinger equation solve பண்ணும்போது கிடைக்கக்கூடிய wave function we can represent in 3 different forms. Those forms are r, pi and theta. And it can be expressed like this: psi is a function of r, theta and pi, that is equal to r of r, f of theta and g of pi. So here we have 3 different functions: r of r, f of theta and g of pi. Out of these 3, the first one, that is r of r, that is called as a radial wave function. Okay, generally psi is a wave function. While solving the Schrödinger wave equation, the solution can be represented in the forms of r, theta and pi. So out of these 3, r is called as radial wave function and theta and pi are called as angular wave functions. Is it clear, students? Yes. Okay, and in the quantum mechanical model we saw that there is no physical meaning for psi. Psi ku endha oru physical meaning me kedaiyadu. It is just a wave function. But the square of psi, that is psi square, that is called as probability density. Probability of finding the electron within the given volume of space, that is psi square. Psi ku endha meaning me kedaiyadu. Psi square is called as probability density. Probability density means the possibility of finding the electron within the given volume of space. Okay, mama? Okay. Now, what we are going to see is how this probability density, that is psi square, how it varies with the distance of the electron from the nucleus. இதை கம்பேர் பண்ண போகிறோம் அப்படின்னா, ஒரு எலக்ட்ரானுக்கும் நியூக்ளியஸ்க்கும் உள்ள டிஸ்டன்ஸ் வேரி ஆகும்போது இந்த ப்ராபபிலிட்டி டென்சிட்டி எந்த அளவுக்கு வேரி ஆகுது அப்படிங்கிறத பார்க்க போகிறோம். ஓகேவா? அது ஒரு கேஸ். அண்ட் ஒன் மோர் கேஸ் இஸ் த டைரக்ஷன் ஆஃப் ஆர்பிட்டால் ஆஃப் அன் எலக்ட்ரான். ஒரு எலக்ட்ரான் எந்த டைரக்ஷனில் இருக்குது அதை பொறுத்து எப்படி probability density vary ஆக போகுது. So there are 2 things we are going to discuss. Those things are the variation of probability density with the distance of electron, and the one more thing is the variation of probability density with the direction from the nucleus. So the distance is called as radial distribution probability, whereas the direction is called as angular distribution probability. So about these 2 things we will see in detail. Okay. Okay students, out of radial and angular distribution function, first we are going to discuss about the radial distribution function. And in the beginning itself we saw it can be solved only for one electron system like hydrogen. So we are going to consider an electron of hydrogen for which the n value is equal to 1 and the L value is equal to 0, which means this electron occupies the 1s orbital, isn't it? Yes. So we are taking the electron of hydrogen atom which is present in the 1s orbital. For this electron we are going to draw a plot. In the y-axis we are going to take r of r square. It is nothing but psi square. Psi square can be expressed in the form of r of r, f of theta or g of pi, that we have seen already. Okay, so now r of r square, that is probability density, is taken in the y-axis, whereas the r means distance of the electron from the nucleus, that is taken in the form of small letter r. So that plot we are going to draw now. Students, this is the plot of that electron present in the 1s orbital of hydrogen. In the y-axis what we have taken r of r square, that is called as probability density, whereas in the x-axis we have taken small letter r, that is the radius, or it is called as distance between the electron and the nucleus. Okay, so we have got a plot like this. இப்போ இந்த plotல பார்த்தீங்க அப்படின்னா this is the smaller distance. So when the இப்போ இது nucleus னு வச்சுக்கோங்க, the nucleus, this is the first shell, here electron is present. When the distance between the nucleus and the electron decreases and the distance கம்மியாகும்போது the probability value will be high, which means for 1s electron it will be very close to the nucleus. That we can conclude from the given plot. ஓகேவா, டிஸ்டன்ஸ் குறையும் போது, டிஸ்டன்ஸ் பிட்வீன் நியூக்ளியஸ் அண்ட் எலக்ட்ரான் குறையும் போது வாட் வில் பி மேக்ஸிமம்? த ப்ராபபிலிட்டி ஆஃப் ஃபைண்டிங் த எலக்ட்ரான் வில் பி மேக்ஸிமம், ஆர் த ப்ராபபிலிட்டி டென்சிட்டி வில் பி மேக்ஸிமம். தட் we can observe from this plot. ஓகேவா. Okay students, so from this graph what we can conclude is when the distance between the electron and the nucleus decreases, the probability will be increases. So this is the radial distribution function which represents the distance between the nucleus and the electron. Okay, at r equal to 0, r equal to 0 in the sense this point here, this is r equal to 0. At this point the probability will be maximum. Okay, at r equal to 0, the r of r square, that is the probability density is maximum. Okay, so that r equal to 0 means there is no distance, the electron will be present in the nucleus. In the nucleus means very close to the nucleus. Okay, now what we are going to do is we are going to consider the volume dv bounded by two radii. So this is nucleus, and it is the spherical orbital. Two volumes we have taken, two radii, one is r and the one more is r plus dr. Okay, and it is a spherical shell, so that the volume of the sphere will be 4 by 3 pi r cube, and this is differentiated in terms of r. It is differentiated, so in the left hand side we will be getting dv by dr, that is equal to 4 by 3 pi r cube. Differentiate பண்ணும்போது பொதுவாகவே டிஃபரன்ஷியேஷனில் இப்போ எக்ஸ் பவர் என்னன்னு வைங்க, எக்ஸ் பவர் என்னன்னா n ஆஃப் எக்ஸ் பவர் n minus 1, that is a general differentiation term. Here it is r cube, so r cube means the 3 will come front, 3, then 3 minus 1 means 2, so 3r square. Okay, so on differentiation we have got dv by dr is equal to 4 by 3 pi 3r square. Then r terms we are going to bring one side, so that on rearranging dv is equal to 4 pi r, 3 gets cancelled, the 3 cancel ஆயிரும். Then we can bring this dr this side, so dv is equal to 4 pi r square dr. Then we are going to multiply both the sides by the term psi square. On multiplying we are getting psi square dv is equal to 4 pi r square psi square dr. ஸோ என்ன பண்ண போகிறோம் அப்படின்னா, நம்ம இதுக்கு முன்னாடி போட்ட பிளாட்டில் எல்லாமே ஒய் ஆக்சிஸில் r of r ஸ்கொயர்னு எடுத்தோம், அதாவது psi ஸ்கொயருக்கு பதிலாக r of r ஸ்கொயர்னு எடுத்தோம். இப்போ அந்த டேமுக்கு பதிலாக தட் இஸ் ஈக்குவல் டு 4 pi r ஸ்கொயர் psi ஸ்கொயர் dr, இதை எடுக்க போகிறோம், அவ்வளோதான். ஓகேவா. Okay, ma. Let us see the remaining. Now, as we draw already, we are going to draw again the radial distribution probability for 1s orbital. In the y-axis it is taken 4 pi r square psi square, whereas in the x-axis the same r is the distance between the nucleus and the electron. So we have got a plot of like this. So at this time the maximum probability, this point, it occurs at a value of 0.52 Armstrong. So in the distance the probability of finding the electron is maximum. And this value already we have studied in the Bohr atomic model. Bohr model படிக்கும்போதே radius and energy கண்டுபிடிக்கிறதுக்கு this value we will use 0.529. Can you remember, students? Yes, the same value is given, is obtained from this plot. Okay, va? Okay, the above plot shows that the maximum probability occurs at a distance of 0.52 Armstrong from the nucleus. So in the distance the maximum probability இருக்குதுன்னா 0.52 Armstrong, and this value is equal to the radius predicted by Niels Bohr. So this is equal to the Bohr's radius, which means the maximum probability of finding the electron around the nucleus is at this distance. அப்போ 1s orbital உள்ள ஒரு எலக்ட்ரானை எந்த டிஸ்டன்ஸில் நம்ம பார்க்கலாம் அப்படின்னா 0.52 ஆம்ஸ்ட்ராங்கில் we can catch it. Okay, வாமா? So from this plot we have got this information. இப்போ மற்ற எலக்ட்ரான்ஸ், இப்போ 1s ஆர்பிட்டாலுக்கு வந்து 0.52 ஆம்ஸ்ட்ராங்னு பார்த்துருக்கோம். இதே 2sஓ 2pஓ இருந்தால் வேறு டிஸ்டன்ஸ் நமக்கு கிடைக்கும். பட் தே வில் பி த மல்டிபிள்ஸ் ஆஃப் 0.52. 0.52ஓட மல்டிபிள்ஸ் அதான் மற்ற டிஸ்டன்ஸ் இருக்கும். ஓகேவா? However, there is a probability to find the electron at other distances also. 1s ஆர்பிட்டாலுக்கு 0.52 ஆம்ஸ்ட்ராங், எல்லா ஆர்பிட்டாலுக்கும் அதே டிஸ்டன்ஸ் கிடையாது. Depending upon the orbitals, the distance value will vary. ஓகேவா? Okay, then the remaining orbitals, for the remaining orbitals the radial distribution functions are given here. For 2s orbital, 3s, 3p, 3d of the hydrogen atom. இப்போ பாருங்க 2s orbital. Okay, so this is the radial distribution function of 2s orbital at r is equal to 0. So அந்த பிளேஸ்ல இருந்து அப்படியே probability லைட்டாக என்ன ஆகுது, இன்க்ரீஸ் ஆகுது. தென் அகைன் 0க்கு வருது, திரும்ப இன்க்ரீஸ் ஆகி ஒரு மேக்ஸிமம் போய் இந்த மாதிரி போகுது. ஓகேவா? இப்போ இந்த பிளேஸில் இந்த பீக் ஏன் வருது அப்படின்னா that is 1s orbital. This peak is for 1s orbital. அப்போ ஒரு பிளேஸில் in a particular place the distance, the probability value suddenly becomes 0. அது என்ன அப்படின்னா the probability distance, the probability density 0 means in that place there will be no electron. அங்கே எலக்ட்ரான்ஸே இருக்காது. And that place is called as nodal plane or nodal surface. புரியுதாமா? எங்கே வந்து எலக்ட்ரான் இல்லையோ அந்த பிளேஸுக்கு பேர் என்னது? நோட் ஆர் நோடல் பிளேன். So here it is the இங்கே density 0, so it is called as nodal plane or node. அதுக்கப்புறமா திரும்ப again the probability increases. So this is for 2s orbital and again decreases. So this is the radial distribution function of 2s orbital. ஓகேவா? அப்போ நோட்னா என்ன? the place where the probability of finding the electron is 0. that is called as node. ஓகேவா? so what is node? the place where the probability of finding the electron is 0. அப்போ for 2s orbital how many nodes are there? only one node. இதுதான் அந்த நோடு. இங்கே என்ன இருக்காது? எலக்ட்ரான் வந்து இருக்காது. ஓகேவா? ஓகேமா. this is for 3s orbitals. in the same way தான். ஃபஸ்ட்டு வந்து 0, திரும்ப இது வந்து 1s ஆர்பிட்டால் ஒரு நோடு, திரும்ப இது 2s ஆர்பிட்டால் அடுத்த நோடு, தென் இது 3s ஆர்பிட்டால். ஸோ here how many nodes are there? 2 nodes. அப்படிதானா? ஸோ அந்த ரெண்டு பிளேஸில் என்ன இருக்காது? எலக்ட்ரான்ஸ் வந்து இருக்காது. there will be no electrons in such place. ஓகேவா? ஓகே, then it is for 3p orbitals. Here 1s 2s they didn't take, only for only the 3s and 3p is taken. Okay va? Okay ma. Then it is for 3d orbital, everything is same. Okay va? Okay, now let us discuss about these plots. For 2s orbital, as the distance from the nucleus r increases, the probability density first increases, reaches a small maximum followed by a sharp decrease to 0 and then increases to another maximum, after that it decreases to 0. இதை பற்றி பார்க்குறோன்னா 2s orbital. இதனை 2s orbital இங்கே நம்ம பார்த்தோம்ல first 0 இருந்து ஸ்டார்ட் பண்ணணும், then it increases a maximum, then falls to 0, then increases to a maximum, again falls to 0. It's about the 2s orbital. ஓகேவா? ஓகே, தென் எந்த ரீஜியனில் the probability density, that is psi square, becomes 0, that is called as nodal surface, or it is called as radial node. Already I told you, the place where the probability of finding the electron is 0, it's called as node, nodal surface or node, or also it's called as radial node, because we are studying about what? Radial distribution function, no? So it's called as radial node. Okay, Mama? Okay, then how to find the number of nodes means there is a general equation is there. We can easily find out using n minus 1. Okay, if you take 1s orbital, here n is a principal quantum number. If we take 1s orbital, the n value is equal to 1. So 1 minus 1, that is equal to 0, which means for 1s orbital there is no radial node. If we take 2s orbital, if you take 2s orbital means the n value is equal to 2, so 2 minus 1, that is equal to 1, which means 2s orbital ku 1 node will be there. If we take 3s orbital, 3s na n value 3, so 3 minus 1 is equal to 2. For 3s orbital, the number of radial nodes will be 2. Okay, so this is the general term we have to remember. The number of nodes can be calculated using the formula n minus 1, where n is the principal quantum number. Okay, okay. In other words, the number of radial nodes for 2s orbital is 1, for 3s orbital it is 2, and so on. Okay, now the remaining cases we are going to see. So, till now we have seen about 1s, 2s and 3s orbitals. Now the 3p and 3d orbitals. So in such cases, the number of radial nodes will be equal to n minus l minus 1. For what orbitals? 3p and 3d orbitals, the number of radial nodes will be equal to n minus l minus 1. Okay, here n is the principal quantum number, l is the azimuthal quantum number. Shall we calculate the number of radial nodes for 3p orbital? எப்படி கண்டுபிடிக்கலாம்? 3p na n is equal to 3, then l is equal to, for p orbital l value is equal to 1, then number of radial nodes will be equal to 3 minus 1 minus 1, that is equal to 1. Okay, so for 3p and 3d orbitals, the number of radial nodes can be calculated using the formula n minus l minus 1. Generally n minus 1, but for 3p and 3d orbitals it is n minus l minus 1. Okay, Mama? So with this radial distribution function over, and now we are going to discuss about the angular distribution function. Appo radial distribution function la what we have studied, we have compared the probability density with the distance between the electron and the nucleus. Okay, Mama? Okay. Now angular distribution function. There we considered distance. Here we will consider about the angle. The variation of the probability of locating the electron on a sphere with nucleus at its center depends on the azimuthal quantum number of the electron in which the electron is present. Already we know, out of the 4 different quantum numbers, the second one, azimuthal quantum number, it will be telling us about the direction of orbitals. Okay, okay, for 1s orbital, what is the value of L? L is equal to 0 and M is equal to 0. Then the value of f of theta is equal to 1 by root 2, g of pi is equal to 1 by root 2 pi. Okay, and we can say that the angular distribution function is equal to 1 by root 2 pi. And in this value, there is no theta and pi terms. So we can say it is independent of the angle theta and pi. Okay, Mama? Okay. So that what conclusion we are going to give is, the probability of finding the electron is independent of the direction from the nucleus. Direction பொறுத்து எது மாற போறது கிடையாது, probability density மாற போறது கிடையாது. That is the conclusion we can give in the case of angular distribution function. Now we are going to discuss about the shapes of each orbital. First, let us discuss about the shape of S orbital. Dear students, it's very important. When we study about this, we must know about the L value and M value. For S orbital, the L value is equal to 0. When L value is equal to 0, M value is also equal to 0. Okay, and the shape of S orbital will be spherical. So that it is spherical in shape. It is 1s orbital, and next 2s and 3s. So in the shapes padikumbodhu, the important things we have to remember is L value, M value, then shape. For S orbital, the L value is equal to 0, so that M value is also equal to 0, and the shape will be spherical. And here they have represented in 3D form. First இருக்கிறது nucleus ma, இது நியூக்ளியஸ். அடுத்து ஒரு பிங்க் கலர், ஒரு ஆரஞ்சு கலர் இருக்குதா, தட் இஸ் 1s ஆர்பிட்டால். தென் ஒரு ஒயிட் கலர் ரீஜியன் இருக்குதா, தட் இஸ் நோடு. நோடுனா தேர் த ப்ராபபிலிட்டி ஆஃப் ஃபைண்டிங் த எலக்ட்ரான் வில் பி 0. தென் அகைன் 2s ஆர்பிட்டால் அண்ட் ஸோ ஆன். இட் இஸ் 3D diagram. ஓகேவா? ஸோ வித் திஸ் S ஆர்பிட்டால்ஸ் ஓவர். Okay, students, so S orbitals have spherical shape. Now we are going to discuss about the shapes of P orbitals. So when we discuss about the shapes, as I already told you, we must be familiar with the L value and M value. Dear students, we know the L value for P orbital. It is equal to 1, and the corresponding M values will be -1, 0 and +1. And in this case, the angular distribution for 1s orbital we saw f of theta is equal to 1 by root 2, then g of pi is equal to 1 by root 2 pi. So that was simple. But in the case of P orbital, it's little difficult, so that is not discussed here. Okay, so the angular distribution functions are quite complex, so it's not discussed here. And the shapes of P orbital is dumbbell shape. This is the shape of P orbital. They will be looking like a clover leaf shape, and it is called as a dumbbell shape. Okay, so that we will see later. Okay, the different values of M ku 3 value irukudha, which means it has 3 different orientations. The P orbitals have 3 different orientations. Okay, and those 3 orientations are designated as Px, Py and Pz. Okay, so the 3 orbitals are designated as Px, Py and Pz. Okay, if we take Px பார்த்தோம் அப்படின்னா, the electrons will be present only in the Px, which means x axisல மட்டும்தான் electron இருக்கும். In y and z there will be no electron. So already we know the place where there is no electron is called as node. அப்படிதானா? அப்போ xல மட்டும் electron இருந்து yzல electron இல்லைன்னா yz is the nodal plane for x. Okay, இதே மாதிரி py பார்த்தோம் அப்படின்னா, the electron will be present only in the y axis, so xz will be the nodal plane for py orbital. If we take pz orbital எடுக்கும்போது, the electrons will be present only in the z axis, so that xy is the nodal plane for pz orbital. Okay, this is the shape of P orbitals. Okay, in 3 different axes. இப்போ first case பாருங்க, this is x-axis, so it is Px orbital. So the orbital is present only in the x-axis. It is like a clover leaf shape, and in y-axis and in the z-axis there is no electron. So here the nodal plane is yz. If you take Py orbital, where is y-axis? This is y-axis. The clover leaf shape is present only in the y-axis. In the x and z-axis there is no electron, so xz is the nodal plane for Py orbital. In the same way, this is z-axis, Pz orbital. So here there is no electron in the x-axis and y-axis. So here the nodal plane is xy. With this, the shapes of P orbitals over. Okay, and 2 more orbitals we have to discuss. Those are D orbital and F orbitals. Now we are going to discuss about the shapes of D orbitals. Okay, students, we know about the L value for D orbital. For D orbital, the L value is equal to 2, and the corresponding M values are -2, -1, 0, +1 and +2. So it has 5 different orientations. Okay, and those 5 orientations are given by the terms dx square y square dz square dxy dyz and dzdx. So these are the 5 different orientations of the d orbital. It's given here. The 5 values are given represented in the form of dxy dyz dzdx dx square y square and dz square. So this is very very important, students. அப்படின்னா d orbital we have 2 different types of orbitals. One is called as axial orbital and the one more is called as non-axial orbital. Okay, and the 3 diagrams are given here. It is dxy orbital, it is dyz orbital, this is dxz orbital, this is x square minus y square and this is dz square. These are the shapes of d orbitals. ஓகேவாமா, சிம்பிளாக நம்ம வரையணும் அப்படின்னா இட்ஸ் வெரி சிம்பிள். இப்போ பாருங்கள், இந்த மாதிரி தான் இருக்கும். இப்படி போட்டுக்கலாம். போட்டுட்டு இதை எக்ஸ் ஆக்சிஸ், இதை ஒய் ஆக்சிஸ். இப்போ dxy நீங்கள் சிம்பிளாக போடணுன்னா இந்த மாதிரி போடலாம். இது நான் ஆக்சியல் ஆர்பிட்டால். ஸோ இந்த லோப் வந்து எங்கே இருக்கும்? இன்பிட்வீன் த ஆக்சஸில் இருந்துச்சுன்னா தட் இஸ் dxy ஆர்பிட்டால். dyz போடனாலும் அதே மாதிரி தான். எப்படி போடலான்னா இந்த மாதிரி போடலாமா? இப்படி போட்டு இதை y ஆக்சிஸ், இதை z ஆக்சிஸ், இன் பிட்வீன் த ஆக்சஸில் என்ன இருக்கும்? லோப் வந்து இருக்கும், டபுள் டம்பிள். ஓகேவா? இது yz, zx போடனாலும் அதே மாதிரி தான். இதை எக்ஸ்ன்னு எடுத்துக்கோங்க, இதை இசட்னு எடுத்துக்கோங்க. இன் பிட்வீன் த ஆக்சஸில் வாட் வில் பி தேர்? க்ளாவர் லீஃப் ஷேப் வில் பி தேர். ஓகே, இந்த மூணுமே non-axial orbitals, dxy dyz and dzx. These 3 are non-axial orbitals and the remaining 2 are axial orbitals. dx square minus y square இருக்குதுல்ல, இந்த மாதிரி போடணும். இதை எக்ஸ்ன்னு எடுத்துக்கலாம், இதை ஒய்ன்னு எடுத்துக்கலாம். எடுத்துட்டு இந்த பிளேஸ் இது ஆக்சியல் ஆர்பிட்டால். dx square minus y square dz square axial orbitals. ஓகேவாமா? Okay, so 2 different sets I have told you. One is axial and one more is non-axial. இந்த மூணு dxy dyz dzx இந்த மூணு non-axial, whereas the remaining 2 are axial orbitals. அதே மாதிரி இங்கே nodal planes இருக்குது. ஓகேவா? ஒவ்வொரு d ஆர்பிட்டாலுக்கும் there are 2 nodal planes. Okay, so with this d orbitals over, and now we are going to discuss about f orbital. F orbital ki L value is equal to 3. So since L value is equal to 3, the m values are varies from -3, -2, -1, 0, +1, +2, +3, which means there are 7 orientations possible for f orbital, and those are given here. F of z cube, f x z square, f y z square, f x y z, f z x square minus y square, f x x square minus 3y square, f y 3x square minus y square. So these are the 7 possible orientations of f orbital, and for every f orbital there will be 3 nodal planes. For p orbital 1 nodal plane, for d orbital 2 nodal planes, and for f orbital 3 nodal planes. And these are the various shapes of f orbitals. Okay, mama, with this the shapes of orbitals over. Shall we recollect from the beginning? For s orbital, what is the L value? L value is equal to 0, m value is equal to 0, spherical shape. Then for p orbital, L value is equal to 1, m value is equal to -1, 0 plus 1, and here the shape will be dumbbell shape and nodal planes will be 1. For d orbital, L value is equal to 2, m value is equal to -2, -1, 0, +1, +2. 5 orientations, dxy, dyz, dzx. These 3 are non-axial orbitals. Then dx square minus y square and dz square, these 2 are axial orbitals. Okay, and here number of nodal planes will be 2. Then f orbitals, L value is equal to 3, so m value is equal to -3, -1, -2, -1, 0, +1, +2, +3. 7 possible orientations. Here nodal planes will be 2. Okay, mama? Okay, students. So with this shapes of orbitals over, kindly go through the video and learn well. Okay, and one more thing we saw, the radial distribution functions. Number of radial nodes will be n minus 1 in the case of s orbital. If it is 3p or 3d orbitals, the number of radial nodes will be equal to n minus L minus 1. Here n is the principal quantum number and L is the azimuthal quantum number. Okay students, go through the video and learn well. Thank you.